Information about the scenario we've got going on here. So it tells us our equation. It also tells us what we're modeling. Okay, if I wanted to draw this out, we have a person, we have a soccer ball, it is getting kicked and going like that. Okay, that is what's happening. That's what we have going on. So it is asking us a couple different things from this problem. So the things that it's asking is, first it's asking for the maximum height of the ball. So in order for us to find the maximum height, we need to look at our graph and see where that would be. That is about here. What kind of point is that on a parabola?
The maximum.
Decline that.
What was the question?
What is that point on the parabola?
The high point.
The
Maximum.
There's a word.
Maximum.
Starts with a V.
Vertex.
I said that.
I didn't hear you, I'm sorry. Okay, I was too busy listening to their nonsense. All right, so when it asks us for the maximum point, okay, it is talking about the vertex of the graph. So real quickly at the top of our paper, we're going to make a little note of this. When it is asking about the maximum height, okay, it is asking for the vertex. To calculate the vertex, okay, does anybody remember the formula for the x coordinate?
Negative b divided by 2.
Negative b divided by 2a. And then how did we find our y?
Plug in.
Plug in x. So if it asks us for our maximum height, that is how we do it every time with these problems. Okay, now, it also asks how many seconds will it take for the ball to reach the ground, okay? So, whenever it reaches the ground, so when it gets here, what's the height when it gets there? 0, okay? So, to find where it reaches the ground, we have to say where it equals 0. So for those, when it reaches the ground, we set equal to 0 and solve. Then the last thing that I want us to put at the top of this paper that is like our key information, okay, is I want us to put something that goes against how we've done all of the other problems. That's just a little bit different. So every single equation up to this point, we have simplified it. We have left it as a radical or as a fraction, correct? Okay. This is the only exception to that. Because if I am measuring someone who's running laps and I have a stopwatch, and they get done running, and I stop the stopwatch, is it going to say the square root of 72? No. Okay? It's going to say how many seconds that is. And it's going to have a decimal. Okay? If I use a measuring tape to see how far a ball gets thrown, okay, is that measuring tape going to have square roots on it? No. Okay? That measuring tape, it might be fractions, but what can we convert fractions to? Decimals. When we are measuring things in the real world, okay, like actual things when we measure it, decimals are okay. Okay, decimals are fine. But when we are doing straight equations, we leave it in exact form, which means we leave it as square roots and fractions, okay? But when we're doing these, decimals are okay. Okay, we're going to round to 2 decimal places. So if you have those 3 things, you should be able to do all of these problems. So let's actually go and look at them. Okay, so we're going to go back to 1A. So we are going to find the maximum height of the ball. So we're going to look at our original equation. What is A in that equation?
Negative 16.
What is B?
90.
What is C? And we're going to plug that in to our equation for our coordinates. Instead of X, though, what does this use instead of X?
H.
Instead of X,
T.
T. Okay? So we're going to say T is equal to negative B over 2A. What is B in this question?
It was
Negative
90.
16. I mean, 9.
Yep. And then A is negative 16. So we get negative 90 divided by negative 32. And what is that?
That
Or positive 2.81 or 812, because does the 2 round the 1? No, so it's just 2.81. Now, to find the height, okay, we take that H equation, but instead of T, we're going to plug in what we just found. So it'll be negative 16 times 2.81 squared plus 90 times T. So instead of T, we do 2.81. And that just gets plugged into our calculator. Is that the shoes you were telling me about?
Yeah, that's the last one.
You're being a very pretty princess, Jerry.
Thank you, Ms. Dawson.
Is it 126.56?
126.56.
Perfect. And now, since we're talking about the height, what units did it use for the height?
T.
Oh, feet.
Feet. So it is 126.56 feet.
Crazy.
So that is how high the soccer ball went. That's a really, really good soccer ball kick in the air to go that high.
I don't know.
That's like taller than. That's like Shaq. Like,
No, please don't. All right, for B, okay, for B, we have to figure out how many seconds it's going to take for that ball to reach the ground. So we're going to take our original equation, negative 16t squared plus 90t equals 0.
He untied in the sheet. Or was attempting to. And he made me laugh.
All right, so we have to solve that. Okay, we can use any of our solving methods. We can factor it. We can solve by completing the square. We can solve by square roots. Well, not this one. This one can't be solved by square roots. And we can solve by the quadratic formula. What do y'all want to do?
quadratic formula.
Okay. So with these problems, you will get to pick what method you use. I don't care what method you use as long as it's mathematically accurate and as long as
It's correct.
it's correct.
Will each method give you the same answer?
Yes, if you do them correctly.
Indeed.
All right, so for this one, let's go ahead and set up our quadratic formula. So we're going to have x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And then we are going to plug into this. So what should I plug in first?
90.
So we get negative 90 plus or minus the square root of
90.
squared minus 4 times
Negative 16.
times
0.
divided by 2 times,
Negative 16.
Hey, Ms. Dawson,
yes.
what if I make a mistake and put the C before the A? Does that really matter?
No. All right, now we get negative 90 plus or minus the square root of what number is going to be under our square root? What is all of this right here equal to?
8,160. No.
Huh?
Mm-mm.
No. 8,100.
8,100. All right, divided by negative 32. Okay, then we just keep going through the simplification process. What is the square root of 8,100?
9.
So we have negative 90 plus or minus 90 divided by negative 32. So at this point, every number we have in there is a real normal number, right? So we're going to have to figure out both cases, okay? So we do negative 90 plus 90
0.
divided by negative 32. So we do get 0 divided by negative 32, which is? Okay, which makes sense. That's where it starts. That's when they first kick the ball. Then the second one would be negative 90 minus 90 divided by negative 32. What is negative 90 minus 90?
Negative 180.
What is negative 180 divided by negative 32?
It is 5.65.
5.625. Does the 5 round the 2?
Yes.
So it should be 5.63.
3.
So when we do this, we will always get a 0. None of the answers will come out of 0.
Not always, no. One of the one we do next won't have a 0. I'll show you what happens when that happens. Okay, so now for the answer of this one, how many seconds is it going to take for it to hit the ground?
5.66.
5.63 seconds.
That's how fast Parker ran his scoring.
That is most definitely not how fast I ran
What
my
a slow boy you are.
40. Not how fast my 40
Oh my god.
All right.
What was your Chevy?
4.8.
Goodness.
Nah.
Parker.
Bro, he's joking. That is not my 40.
That is his 40.
You think that's his 40? Probably. I think everybody
I don't know.
gets a 40 at this level. Everybody should get a 40.
The first time I ran it was a 5.3. That was many weeks ago.
All right. Now we're going to look at the second question. Okay. So the second question is a little bit different. So for this one, an apple is launched directly upward at 64 feet per second from an 80-foot tall platform. Okay. So this apple is being launched, okay, from a platform all the way up here, and then it's getting sent flying. Okay. So that's what's happening here. And it says that the equation for this is this equation here. So we have two parts to this. First, it's asking us for the maximum height. What is that asking us to find? The vertex. Okay. Then the second thing it's asking us to find is how long it's going to take to reach the ground. What do I need to do to find when it reaches the ground? Set it equal to 0. Okay, so for our vertex, okay, we're going to do T is equal to negative B over 2A. In this question here, what is our B?
B is 64.
What is our A?
Negative 16.
So we get negative 64 divided by negative 32.
So it's like 2.
It is 2. Then we take that 2 and we plug it back into that equation. So we're going to get H is equal to negative 16 2 squared plus 64 times 2
Equal to.
plus 80.
Oh yeah. That's right.
Okay, and then we just type that into our calculator and see what we get.
I got 176.
I still do that already.
It shouldn't be 176. Did you forget the negative sign at the front of 16?
144.
It should be 144. Me come look at it, Joey?
144.
Yes. All right.
Is it this
Oh, you didn't square the 2. So right here, we got 2.
And it irritates me so bad. Like, why are you stopping at this?
All right. Now, okay. So I'll come look. So we get 144 feet. Okay, now, the second one, we have to set and make it so that it reaches the ground. So we need to set it equal to what?
0.
So we are going to do negative 16t squared plus 64t plus 80. We have too much talking, so go ahead and quiet, please. Equals 0. I want y'all to plug that into your quadratic formula and solve.
So do you see how it has that exponent hanging out? You just have to leave that.
So anybody else have a calculated question that needs answered?
I do look at you a lot when I'm teaching. I think it's because we don't look so judgmental. If I look at Thomas, it makes me feel behind the judge.
She sees the hate.
It's just because he looks like I didn't know that. I didn't know that.
Show me a picture too.
I knew
Gives me the creeps.
No, you have to do it like when you're saying hi to somebody.
What's up?
Like when you're walking up to somebody. She doesn't have the magic. No, she doesn't have the magic
I walked
fingers.
past him and I
Like,
did.
it's
that. Just do
like,
your math, just do your math.
It looks weirder when you do it. It looks like you're ready to shoot.
I really feel like you're a creep. That feels like something a creepy old man would do.
Yeah.
how would you know?
There's a lot of creepy.
There's a lot of creepy old men.
Wait, ask that question. It made me uncomfortable.
All right, so we plug into this, and we plug in 64, negative 64 plus or minus the square root of 64 squared minus 4 times negative 16 times 80 divided by 2 times negative 16. We get that, we go from there, and we get negative 64 plus or minus the square root of
9,216.
divided by negative 32. What is the square root of 9,216?
96.
Oh, she's 96.
Divided by negative 32. So we have to do both cases. Okay, so our first case, we will have negative 64 plus 96 divided by negative 32. What is that going to be? Negative what? Negative.
Could we divide first?
Hmm?
Could we divide both of them before?
And then add them? Yeah. It would be a little bit more complicated though. But you can do it that way. You should get negative 1. Yes.
Wait, I got 0. Oh wait, never mind.
That was so understand it now.
You need another one?
That was so cool.
Sorry, that was my bad. All right. So the first one you get negative 1 for. Then the second one we have minus 96 divided by negative 32. Thomas, please stop talking. What do we get for that one?
5.
All right. So can I have a negative second? No. Okay. So our answer is 5 seconds. But I do want to take a second and discuss why it is negative 1 right there. So you remember how this apple was being thrown from 80 feet in the air?
Yeah.
So when we're talking about this real life scenario, obviously nothing is happening past that. But the graph would continue down and that's where it would cross at. That purple part isn't happening in the real world because no one is going to be able to take the apple and throw it from all the way down here and go, woo. But because we're already have this part of our graph, but that other part still exists in like a theoretical sense. If you're about to ask about the apple, Ashton, I don't know. Okay? I don't know. All right, flip to the back. All right. Now we're going to look at number 4. Okay. It really gets weird whenever you think about how fast the fireworks are being launched and then compare that to the apple. That one's wild. Anyways. Okay. So, number 4. Okay? A penny is dropped off of the Empire State Building, which is 1,250 feet tall. If the penny's...
Busted that bit.
What?
Play.
It does it 3 times.
Okay. It could still injure someone, but like, I don't know. It would depend. Just be quiet and let us do the math. I didn't say it would. No, it doesn't.
What are you reading?
All right. Maddox, please go away. Maddox, please go away. All right. A penny is dropped off of the Empire State Building, which is what, y'all, please be quiet. Okay. It is 1,250 feet tall. If a penny's pathway can be modeled by the equation negative 16t squared plus 1,250, how long would it take for a penny to strike a 6-foot tall person? Okay, so if when it hits the ground, it's equal 0, if it's going to strike a 6-foot tall person, it needs to equal what?
6.
So what we're going to do is we're going to take negative 16t squared plus 1,250 and set it equal to 6. Yeah, or for what?
Strike, it doesn't matter. You can strike them in the shoulder.
Can you have a sticky note? All right, pretty much. So for this one, all right, obviously we can use the quadratic formula to solve any quadratic. However, for this one, that's not the quickest or easiest way to do it. This one has a square and a constant. So the easiest way to do it when it's a square and a constant is to solve by square roots. So we would just get t squared by itself. So we would subtract 1,250 on both sides. And we get negative 16t squared is equal to negative 1,244. Divide both sides by negative 16. We get t squared equals 77.75, I think, if I remember correctly. Okay, so on the test, you can answer these any way you want to. I'm just going to show us which type of questions would be easier to work by other methods than the quadratic formula. But the quadratic formula can be used for all of them.
Do we square that?
How do I undo a square?
Square root it.
Square root. So we get t is equal to what?
T.
We have positive, negative.
8.82.
8.82. Now, for this question, would I use the positive or the negative answer? Positive. Okay, because we have 8.82 seconds. And again, that comes from if we have our Empire State Building right there, okay, and someone throws something off the top of it, that gives us half of our parabola. The other half would happen from the other side, okay? Obviously, no one's going to be able to go from here, though, and throw the penny over the Empire State Building. Okay, Thomas. All right, now we're going to look at number 5, okay? So number 5 says some fireworks are fired vertically into the air from the ground at an initial speed of 80 feet per second. The equation of this object's height h and time t seconds after launch is given by that, okay? How long will it take the fireworks to reach the ground? When it says reach the ground, that means we automatically need to do what? Equal to 0 and solve. So we're going to do negative 16t squared plus 80t equals 0. Now, this one, again, we can use the quadratic formula. However, sometimes when it's in this form where it's got t squared and t, the easiest thing to do is actually find the GCF. So like in this one, the GCF is negative 16t, which leaves with t minus 5 equals 0. And then we just do negative 16t equals 0. Divide both sides by negative 16. What does t have to equal? Yes.
Why do all these start with negative 16?
Gravity. That's the effect of gravity in feet per second.
Okay.
That is why they all start with that. So t is going to have to equal what in this one? 0.
Times equals 0.
All right, now we can do t minus 5 equals 0. What do we do to solve that?
Plus 5.
So t equals. So which one of those would be my answer? 5 seconds.
Why are these 5 seconds?
Okay. But yeah, Jairi, good question though. It's because of gravity's effect on feet per second in the downward direction.
When Ethan comes back down, water.
All right. So from here, okay, I want us to go ahead and we're going to look at number 7. Okay, so number 7. This one's worded a little bit differently. Okay, it says Eva is jumping on a trampoline. Her height h at time t can be modeled by this equation. Would Eva be able to reach a height of 14? Okay, so for us to be able to figure this out, we need to know how high Eva jumps. Okay, so we need to figure out the max. How do I find the max?
You draw the picture and then take the top one.
It is the top part, but how do I calculate it?
Vertex.
Vertex. Okay, so we're going to do t is equal to negative b over 2a, and then plug that into h. So why don't y'all do that for me?
Negative
0.63.
It is. So it will be 0.63. Is that positive or negative?
It's negative.
I got positive.
It should be positive, right?
It should be.
Yeah.
Yeah. All right. So then we take and plug that into our function. So we get 0.63 squared. And then we plug it in here as well. Plug that into our calculator, and what do we get?
What is that?
Crazy that you got that to figure out.
It's a triple berry limeade slammer.
24.
Don't you have another copy on your desk too?
Yeah, I got 2 this morning because this was a new slammer and I'd never tried it, so I didn't know if I would like it. And then my coffee didn't taste good.
Oh, that makes sense.
Whoa.
Slammers, the ones with
Did it 12.25.
So slammers are the ones with the red,
Hey.
right?
Here.
Those are good. I tried the.
I like these a lot. They're my favorite.
I can't remember which one.
They're all good. The summer ones are the best one. All of the summer ones are good. All right. So this one is 12.25 feet. All right. Now, okay, we have one last question we're going to do, okay? So this last question, it has a couple different parts to it. So we're going to split it up, and half the class is going to do one part, half the class is going to do the other part, then we're going to put it together, okay? So it says an astronaut on the moon throws a baseball upward with an initial velocity of 10 meters per second, letting go of the baseball 2 meters above the ground. The equation of the baseball path can be modeled by h is equal to negative 0.8 t squared plus 10t plus 2. So on the moon, we have the equation h is equal to negative 0.8, which that is the effect of gravity in meters per second on the moon. Okay, and we have t squared plus 10t, which that's our initial velocity, plus 2, that's how high it is above the ground. Then it also gives us the same experiment as done on Earth, which is modeled by the pathway h is equal to negative 4.9t plus 10t plus 2. And that is, we're going to put Earth, and then we're going to do negative 4.9, or we'll do h. H is equal to negative 4.9, which is meters per second of gravity on the Earth, t squared plus 10t initial velocity plus 2 is the height. And what it wants us to do is it wants to figure out how much longer the ball needs to stay in the air on the moon compared to on the Earth. So if we're talking about how long it needs to stay in the air, what do we need to know? Do we need to know the max height or when it hits the ground? When it hits the ground. So to find when it hits the ground, we figure out when it equals 0. So we're going to set both of these equal to 0 and solve. So what we're going to do is we're going to do the quadratic formula with both of these. Okay? And instead of making everyone do both of them, this half of the room, I want y'all to do the moon. This half of the room, I want y'all to do Earth. Okay? So on this side, we're going to calculate the moon and its solutions. And over here, we're going to calculate the Earth and its solutions. And we are just plugging into the quadratic formula. Please, please, please do not ever try to factor when there are decimals involved. Don't do that to yourself. Don't try to complete the square when there's decimals involved. Just use the quadratic formula, please.
That side of the room is that room, not the Earth. That's yeah, where the Earth is. What's your question? What your question was it?
How many questions do you
I have a decimal.
That's okay.
Yeah.
What should I round to?
I never said
2 decimal places.
I never said it. That's right.
And you can take the square root of this.
Somehow I'm biased.
That's my brother makes it.
It's annoying.
Ew.
I feel bad because that kind of happened to my brother. You are smart, my dear.
Smart in your own ways. Tell it.
All right. So if you plugged in for the moon, okay, the equations, solutions you should have gotten are negative 0.2 and 12.7. If you plugged into the equations for Earth, you should get negative 0.18 and 2.22. Can the negatives be our answer here?
Yeah.
No.
No, doesn't make any sense. Okay, so we get 12.7 seconds for how long the ball is in the air on the moon, and 2.22 seconds for how long the ball is in the air on Earth. How would I figure out how much longer it stays in the air on the moon?
Subtract.
Yeah.
So we do 12.7 minus 2.22, which gives us what? Not 9.
Like
10.4.
10.
10.48. And so our answer is 10.48 seconds. And we are done for today.
Let's get this game going.